In this video, we'll look at another use of SD, which is establishing that sets of sentences are inconsistent. So a set of sentences, gamma, is inconsistent in SD if and only if there is a sentence P such that gamma entails P, P is derivable from gamma, and not P. The negation of P is also derivable from gamma. And because of the principle of explosion, there's actually an alternative way of defining this. You can also say that a set of sentences is inconsistent in SD if and only if every sentence is derivable from that set. Because if you can derive a sentence and its negation, then what you can do is you can use negation introduction and negation elimination to prove any sentence. So if a set is inconsistent, then it will end up entailing every sentence, or every sentence will be derivable from it. Um, Inconsistencies can be difficult to find. So when you're demonstrating that a set is inconsistent, you often won't, or usually, you're not actually going to know what sentences, or which sentence you can derive that sentence and its negation for at first. So what you'll need to do is you'll need to work top down for a while and go through and draw inferences from the set until you can finally identify a goal sentence. You figure out what where you can actually get a contradiction, and then you've got a goal that you can work towards. So we'll look at an example of this. So we'll look at this example. We will show that this set right here is inconsistent in SD. So I've already gone through and written all of the sentences in the set into a derivation as primary assumptions, and just made the derivation basically as big as would fit onto the screen because we don't know how long this is going to be. So looking at this, it's not really clear what our goal sentence is going to be. So what we can do is we can just start working top down and making inferences from this. And we'll just see if we come up with anything that gives us, any ideas as to what we can do. So from line 4 here, we can break this up using conjunction elimination. So we'll get not E and not G here. Then we have, let's see, we've got a not G here, and if not G, then H. So we'll use conditional elimination to get H. So this will be 3 and 6 conditional elimination. And and then since we've got the H, we can get F. So another conditional elimination for F, lines 2 and 7, conditional elimination. That hits everything sort of easy and straightforward that we can get from the assumptions. So now we're going to have to start thinking about things. At this point, though, there is a strategy that's going to suggest itself. So we have not G here, and then we've got G as a subcomponent of a sentence up here. And so if we could get G, then we can get a contradiction between these two. So let's set G as our goal sentence. So how do we get G? Well, it's part of this biconditional here. So if we had the other part of the biconditional, this if I then F, then we would be able to get G by biconditional elimination. So then this would become our new goal sentence, if I then F. And so then how can we get this? Well, we have F. And remember your paradox is a material implication. given the consequent of the conditional, whoops, we can actually derive the entire conditional. We just set up for, we'll need a new subderivation here to set up for conditional introduction. Assumption for conditional introduction. And then on the next line, we will just reiterate F from line 8. And there, we have derived if I then F, and that lets us get G by, this is lines 1 and 11, by conditional elimination. And then we'll take out all of these lines here, or these rows, because we don't need these. I'll fill in these scope lines. And notice that we don't need to, I mean, the G is here, the not G is up here. We don't actually need to reiterate the not G down to the bottom of the subderivation. In these, I mean, in general, when you're working with, you're finding inconsistencies, and when you're working with negation introduction and negation elimination, you don't actually have to have the contradiction right next to each other at the bottom of the subderivation. Very often you'll find one and then you'll get the other one. And so it's fine for them to be separate like this.